Before light, before matter, before movement or distance or thought, there was nothing. But even nothing is too much, because when we say nothing, we picture a dark, empty room, a blank page, or the stillness between two sounds. But in this before there was no room, no page, no silence, because there was no time to contain stillness, no space in which nothing could reside, not even the possibility of being. Physicists call it a singularity, a place where all the laws of physics bend, break, collapse into themselves. But this word, singularity, is not an explanation. It's a whisper in the dark, a way of admitting we do not know what came before the beginning, because there was no before. Time had not begun. And yet, somehow, from this unknowable, timeless hush, something began to stir. Roughly 13.8 billion years ago, the universe, as we know it, was born. Not inside something, but as the something itself. Space did not expand into a void. It created the void as it expanded, not in a moment, but as the very first moment. Imagine everything, every galaxy, every star, every atom in your body compressed into a single point, a point that had no size, no inside, no edge. This point wasn't in the universe, it was the universe. And then, suddenly, without warning, it changed. A surge, a pulse, an unfolding of imaginable energy and expansion, the Big Bang. But it wasn't a bang. There was no sound, no air to carry it, no explosion in space. It was the explosion of space itself. Everywhere, all at once, the fabric of reality inflated, violently, rapidly, silently, a trillion times faster than the blink of an eye. This was the moment when time began to flow. Within the first flicker of existence, a heartbeat so brief it makes our seconds seem eternal. The universe was a storm of pure energy, no light yet, no matter, only heat, pressure, chaos, a quantum firestorm, where the very laws of physics were still being written. In these earliest moments, all the fundamental forces of nature were unified: gravity, electromagnetism, the strong and weak nuclear forces, bound together as one. But the universe didn't stay still. It grew, it cooled, it changed. At around 10 to 36 seconds, a phase called cosmic inflation began. The universe expanded exponentially, from the size of a subatomic particle to the size of a grapefruit, in less than a heartbeat. Then, from the seething energy, particles began to form. Quarks, leptons, bosons, the tiniest building blocks of all matter. The four fundamental forces separated, like colors spilling from white light. Gravity pulled away first, then the strong nuclear force, then the weak, and finally the electromagnetic force. The rules of reality had now taken shape. The universe was still blazing hot. A thick, glowing fog. Light couldn't escape yet. Every newborn particle was caught in a storm of collisions. Photons bounced wildly, trapped in a plasma of chaos. But even in that searing darkness, the seeds of everything were beginning to form. Quarks joined to make protons and neutrons. A delicate, dangerous dance of creation. Some disappeared, some survived. And from those survivors, in time, would come stars, planets, oceans, even us. For now, though, there were no shapes, no stars, no galaxies, only an expanding ocean of potential. The universe had opened its eyes, and in its first breath had begun the longest story ever told. The universe had been born, and yet it was still invisible. It existed, yes, vast, growing, unfolding, but in these early stages it remained hidden behind a veil so thick, so turbulent, that not even light could escape. There was no sky, no stars, no constellations to gaze upon. Instead, there was a dense, scorching sea of energy and particles, a cosmic fog, composed of protons, electrons, neutrons, and photons, all tangled together in a chaotic storm. Light existed, but it had no freedom. Every time a photon tried to move, it was instantly scattered, bouncing off another particle like a prisoner chained in a room with no exit. The universe, at this point, was a glowing silence, illuminated from within, but utterly blind. This primordial state is known to scientists as a plasma, a superheated fluid of charged particles in constant collision. The temperatures were so high that atoms could not yet form, electrons were not bound to any nucleus, and matter remained in a violent, disassembled state. For hundreds of thousands of years, the cosmos existed in this condition, hot, opaque, and chaotic. Yet, even in this tempest, something remarkable was happening. The universe was expanding, and as it expanded, it cooled. Slowly, ever so slowly, collisions between particles became less frequent. The energy of the early cosmos began to spread out, to stretch thin across the growing fabric of space-time. The universe, once a furious blaze, began to calm, and then something truly profound occurred. Roughly 380,000 years after the Big Bang, the temperature dropped to a point where electrons could finally settle down. Instead of racing freely through space, they began to attach themselves to protons, forming the first simple atoms, primarily hydrogen. This process is known as recombination, and it changed everything. With electrons now locked into atomic orbits, the fog began to lift. For the first time, photons, the particles of light, could travel without constant interruption. They were no longer scattered at every turn. Instead, they moved freely, crossing the cosmos in straight lines. And in that moment, the universe became transparent. It was the first time that light could exist as light, not trapped or crushed, but radiant and free. It was, in a sense, the first morning in the history of everything. This light, released so long ago, is still with us. It has traveled through time and space for nearly 14 billion years, stretched and cooled along the way by the expansion of the universe. What was once a searing white brilliance is now a faint whisper in the microwave spectrum, invisible to the naked eye, but detectable with sensitive instruments. This is what scientists call the cosmic microwave background radiation, the oldest light in the universe. It bathes us from every direction, filling space like an ancient memory. In that light, we can see the first patterns of matter, the tiny ripples and clumps that would one day become galaxies, stars, planets, and life. And yet, despite this breakthrough, this release of light, the universe was still a very dark place. There were no stars, no suns, no moons or planets. What followed was not a glorious dawn, but a long, slow night. This era, after recombination but before the first stars, is known as the Cosmic Dark Ages, a time when hydrogen and helium filled the expanding void, but without light sources of their own. The universe was quiet, cold, and mostly empty, apart from a thin, invisible gas drifting through space. There were no structures yet, no shapes, no sounds, just the vast, expanding darkness and the faint, ancient light from the cosmic background fading into silence. But in this apparent stillness, another force was at work, one that never sleeps, never rests. Gravity. Slowly, silently, patiently, gravity began to pull things together. The lightest particles began to gather, not quickly, not dramatically, but with purpose. Clouds of hydrogen gas started to clump under their own gravity, pulled into denser and denser knots. Small imperfections in the distribution of matter, tiny ripples left over from the Big Bang, became the seeds around which structures would form. The universe, though still dark, was no longer idle. It was preparing. In the vast and silent cold, gravity was building the scaffolding for everything that would come. It gathered clouds of gas into greater and greater densities. And deep within those clouds, in places where matter compressed under its own weight, pressure and temperature began to rise. until finally, after hundreds of millions of years of silent preparation, something extraordinary was about to happen. A new kind of light, a new kind of fire, not the chaotic glow of a young universe, but the focused, controlled burn of a star. But that is a story for the next chapter. The darkness that followed the birth of light was not empty. It was quiet, yes, impossibly vast, profoundly still, but it was pregnant with possibility. For hundreds of millions of years after the first photons began their journey across the cosmos, there were no stars to illuminate the sky. Only cold gas drifting through space, thin and invisible, made almost entirely of hydrogen and helium, the two simplest elements, forged during the first few minutes after the Big Bang. The universe was now a canvas, blank but prepared. Its laws had settled, its matter had cooled, its light had been released, and now gravity began its long and tireless work. From the faint patterns etched in the primordial plasma, gravity had already begun to pull, ever so gently, on the threads of matter scattered across space. Minute fluctuations in density, left behind by quantum ripples from the very birth of the universe, began to grow. Denser regions attracted more matter. The rich grew richer, and voids became emptier. Gas fell inward, slowly at first, then with more urgency, forming vast, diffuse clouds. These were the first structures in the universe. Dark matter, the invisible scaffolding that outmasses normal matter 5-1, silently shaped the framework upon which galaxies would later form. But normal matter, made of protons, electrons, and neutrons, was now beginning to collapse inward under its own gravity. Imagine a colossal cloud of hydrogen gas, light years across, drifting alone in the deep blackness. As gravity pulls it inward, the center of the cloud grows denser. Atoms slam together more frequently. Friction and pressure rise. Heat builds. And then, somewhere, sometime, in a corner of this cooling, dark universe, a critical threshold is crossed. The temperature in the core of one of these collapsing clouds climbs above 10 million degrees Celsius. And at that unimaginable heat, something truly miraculous happens. Nuclear fusion begins. Hydrogen atoms, crushed together under immense pressure, begin to fuse. Two protons overcome their natural repulsion and merge, forming helium. In the process, a small amount of mass is converted directly into energy, pure, radiant, blazing energy. A new light bursts into the darkness. Not scattered background radiation, not the faint memory of the Big Bang, but the first star. Its light is different, focused, intense, fierce. It shines steadily, burning from within, a thermonuclear engine held in balance by the delicate dance between gravity and fusion. Gravity pushes inward, fusion pushes outward, and in this perfect balance, the star is born. It is the first of its kind, but it will not be the last. These early stars, known as population 3 stars, were unlike any stars we see today. They were massive, dozens, even hundreds of times the mass of our sun. And because they formed from pristine hydrogen and helium, untouched by heavier elements, they lived fast and died young. Their lives were brilliant and brief, just a few million years, before they ended in cataclysmic supernovae, scattering their innards back into the cosmos. And in those violent deaths, the universe unlocked a new secret. For inside these stars, in their hot, dense cores, fusion had done more than just shine. It had forged. It had taken hydrogen and built helium, then carbon, then oxygen, nitrogen, silicon, and even iron. And when these first stars exploded, they flung those newly forged elements out into space, into the very clouds from which new stars would one day form. Thus began the great cosmic cycle, star birth, star death, and the seeding of the universe with the ingredients for complexity. Everything heavier than hydrogen and helium, every atom of calcium in your bones, every molecule of iron in your blood, every grain of sand, every drop of water, every tree, every mountain was born in a star. We are not just the children of stars, we are their ashes. From this point forward, the universe would never be the same. It was no longer a silent expanse of gas and gravity. It was now a place of light, of fire, of transformation. Stars began to gather into groups, groups into clusters, clusters into galaxies. The structure of the modern cosmos began to emerge. Spiral arms, black holes, nebula, suns and planets. The architecture of the night sky had begun. But this great cosmic construction, grand as it is, was still incomplete. Because in all this light and matter and motion, there was still one thing missing. A world like ours. A small rocky planet, with oceans and weather and mountains, with chemistry rich enough for life. That part of the story, the birth of the earth, was still to come. The stars had begun to burn. One by one, across the expanding darkness, they ignited, their light piercing the silence, their cores forging the elements of a richer universe. The first stars had lived fast and died young, exploding in magnificent supernovae that hurled stardust into the surrounding void. And from this dust, the cosmos began to build again. It was no longer just hydrogen and helium drifting through space. Now, the gas clouds were laced with carbon, oxygen, iron, the seeds of rock, oceans, atmospheres, and perhaps, someday, life. But individual stars are not enough to shape the vast architecture of the universe. To understand the grand design, we must zoom out, far beyond a single star, and witness the birth of galaxies. Galaxies are the cities of the universe, islands of light in a dark ocean, made not of buildings or streets, but of stars, billions, sometimes trillions of them, bound together by gravity, spinning in vast and elegant spirals, or clustered into chaotic spheres. And yet, their formation began from the humblest of motions. In the wake of the Big Bang, as gravity pulled together the early clouds of gas, not all of them collapsed directly into stars. Some remained diffuse, great rotating disks of gas and dark matter. These structures, invisible to the eye, were shaped by the tiniest asymmetries in the primordial universe, regions just slightly denser than their surroundings, tugging more strongly on nearby matter. As they grew, they spun. Why? Because in a universe filled with randomness, nothing collapses perfectly. Even the slightest imbalance creates rotation. And in space, once something begins to spin, it keeps spinning. Over millions of years, these vast, spinning clouds flattened into disks. Stars began to form within them, first in clusters, then in sweeping arms, then in glowing cores. This was the birth of the first proto-galaxies. But these early galaxies were not quiet cities of starlight. They were turbulent, violent, chaotic. They collided, they merged, they tore each other apart. Gravity does not respect solitude. When galaxies pass near each other, they pull on one another, stretching stars into long, luminous trails, flinging entire star systems into deep space. Sometimes, two galaxies spiral inward and merge, forming a new, larger galaxy in the process. In these cosmic encounters, beauty and destruction walk hand in hand. Meanwhile, deep in the hearts of many galaxies, something darker was stirring, supermassive black holes. Born from the collapse of massive stars, or perhaps formed through mysterious processes we still don't fully understand, these black holes sat at the centers of galaxies, quietly growing, pulling matter inward, spinning at near light speed, warping time and space around them. Some became quasars, beacons so bright they outshone entire galaxies, powered by matter swirling at the edge of oblivion. Others remained silent, invisible engines shaping the orbits of stars for billions of years. And yet, for all their violence and scale, galaxies were not scattered randomly across the universe. They began to arrange themselves into a vast, interconnected cosmic web, filaments of matter stretching across unimaginable distances, linking clusters of galaxies like threads in a spider's web. Between them lay immense voids, cold, dark regions where few galaxies formed. This structure, too, was born from the original ripples of the Big Bang, amplified over billions of years by the pull of gravity and the quiet influence of dark matter, that invisible, unknowable substance that outweighs normal matter 5-to-1, shaping the universe not with light, but with presence. Today we can map this great cosmic web. With telescopes that see not just invisible light, but in infrared, microwave, and X-ray, we trace the large-scale structure of the universe. Clusters of galaxies, strings of superclusters, walls of cosmic architecture stretching for hundreds of millions of light years. It is breathtaking. To look at the universe on this scale is to glimpse something beyond imagination, a pattern written in gravity and time, a dance choreographed by physics long before the Earth was born. And in one quiet corner of that web, within a modest spiral galaxy, a yellow star began to form. Around it, a disk of dust and gas had started to swirl. From that dust, something was taking shape. Not a star, not a galaxy, but a small, rocky world, a world that would one day awaken. But for now, we remain at a distance, watching the galaxies spin and collide, listening to the slow rhythm of the universe unfold. In a quiet arm of a spiral galaxy, within a modest lane of stars known as the Orion Spur, a cold, dark cloud of gas and dust began to stir. It was nothing unusual, just one of countless interstellar clouds drifting through the Milky Way. But in this one, something had changed. Perhaps it was the shock wave from a distant supernova. Perhaps it was a gentle gravitational nudge from a passing object. Whatever the cause, the cloud began to collapse. Gravity took hold, pulling material inward, gathering atoms into a dense, spinning core. Around it, the remaining gas and dust flattened into a wide, rotating disk. This was the solar nebula, a turbulent cradle of creation stretching billions of kilometers across. And at its heart, a new star was forming. As matter spiraled inward, the growing pressure and heat at the core triggered a transformation. Hydrogen atoms began to fuse into helium, releasing energy. A balance formed between gravity pulling inward and radiation pushing outward. The sun had been born. It was a young and temperamental star, unleashing solar winds that swept across the disk, but it now radiated light, heat, and power, the center of its planetary family. And within the swirling debris around it, a second miracle began to take shape. Tiny grains of rock and metal collided and stuck. Some shattered, some grew. Over millions of years, dust became pebbles, pebbles became boulders, and boulders merged into planetesimals, small worldlets with growing gravitational pull. They swept through their orbits, colliding, accreting, smashing into one another. Some grew large enough to dominate their regions of space. These were the protoplanets. In the hot inner part of the disk, close to the sun, only rock and metal could survive. Here, 4 rocky worlds emerged: Mercury, Venus, Earth, and Mars. Farther out, in colder space, gas and ice were more abundant. There, the gas giants took form. Jupiter and Saturn, massive and crowned with rings, followed by the icy giants, Uranus and Neptune. Beyond them stretched a wide belt of icy debris, the Kuiper Belt, home to dwarf planets, frozen bodies, and comets, remnants of the system's chaotic beginnings. For the early solar system was anything but peaceful. Protoplanets battled for dominance. Some collided violently, fusing or shattering. Others were flung into deep space, lost forever. One of these collisions reshaped Earth itself. A Mars-sized object slammed into the young planet, tilting its axis, cracking its crust, and sending molten debris into orbit. From that fiery wreckage, a sphere of rock reassembled. A moon was born. Gravitationally bound to Earth, it helped stabilize the planet's tilt, softened the chaos of seasons, and stirred the tides, rhythms that would one day matter. As the chaos calmed, the sun settled into a steady burn. The planets found their orbits, and between Mars and Jupiter, a leftover field of rocky debris formed the asteroid belt. A reminder of a planet that never was. Closer in, a narrow zone emerged. Not too hot, not too cold, where liquid water could exist. The habitable zone. And in that zone, on a young Earth now blanketed in volcanic gases and storm clouds, the stage was being set for the next act in the cosmic story. The early Earth was violent and restless. Its crust churned with lava. Its skies raged with lightning and acid rain. But water began to appear, first as steam venting from deep inside, then falling in endless storms, filling basins, carving valleys, cooling the fire. Oceans gathered, atmosphere thickened, volcanoes released carbon dioxide and methane. The surface began to cool, forming continents, trenches, and islands. The moon, ever present, sculpted the tides, daily pulsing movements that mixed oceans and shaped coastlines. Above, the young sun blazed. Below, Earth's interior churned with heat and metal, creating a magnetic field that would one day shield life from deadly radiation. And in the shallow pools and deep sea vents, something extraordinary was beginning. Not yet life, but the chemistry of life. Molecules forming chains, membranes, cycles, accidents of structure and energy that slowly, over countless iterations, began to resemble purpose. At this point, Earth was only one of many planets, each with its own history, its own path. But something on this world had aligned. A balance of heat and liquid, atmosphere and stability, a rare harmony, fragile and temporary, but enough to allow the spark of biology to take root. No one knows exactly how or when it happened. Perhaps it was in a tide pool, perhaps near a hydrothermal vent in the deep sea. But somewhere on this young, cooling planet, life began. The solar system, born from dust and fire, had become a stage for the next transformation. Not just matter, but meaning. Planets orbiting a steady star, one of them slowly waking to awareness, bathed in sunlight, shaped by gravity, time, and chance. And though the galaxies still danced far beyond, and black holes spun in silence, something had changed. In this one small corner of the cosmos, the universe had become aware of itself. The Earth was young, still cooling from its violent birth. Its surface hissed with volcanoes, its sky thick with gas and lightning. Seas were forming dark, restless, and rich in chemicals. No continents, no forests, no creatures roamed the land. But in this lifeless world, something extraordinary was beginning. Not life yet, but the conditions for it. In the oceans and along the rocky coast, simple molecules swirled. Hydrogen, carbon, oxygen, nitrogen, they came together in chains. Some formed amino acids. Others became lipids, sugars, and nucleotides. Many broke apart again, but some persisted. Sparked by lightning, warmed by volcanoes, concentrated by tides, Earth's chemistry was shifting into something more. Scientists call it prebiotic chemistry, the slow, natural assembly of complex molecules from simpler ones. It's not rare. We've seen similar compounds form in lab experiments, and even on meteorites. But somewhere on Earth, under just the right conditions, a pattern began to emerge. A kind of organization that could not yet be called life, but that was moving steadily toward it. Perhaps it began in shallow pools, dried by sunlight and re-wetted by storms. Perhaps it happened deep underwater, near hydrothermal vents rich in minerals and heat. We don't know exactly where, but we know what came next. Some molecules began to self-replicate. That was the turning point. Replication meant survival. It meant change. Some copies were flawed, slightly different, and those differences mattered. In a chaotic world, certain molecules became better at staying together, at lasting longer, at making more of themselves. It was the birth of evolution long before cells, long before genes. Life began not with a spark, but with a rhythm, a dance of chemistry learning, very slowly, to remember itself. Eventually, small structures began to form. Membranes enclosed chains of molecules, protecting them from the harsh outside world. These primitive bubbles, protocells, weren't alive in the full sense, but they were close. Inside them, reactions happened more efficiently. They grew, they divided, and the best ones stayed intact. Time did the rest. Over millions of years, those protocells evolved into the first true cells, simple, single-celled organisms, able to grow, process energy, and reproduce. They were tiny, fragile, invisible, but they were alive. They marked the beginning of biology. Life's earliest forms were likely similar to today's bacteria and archaea, single-celled, without nuclei or organelles. They fed on minerals, heat, and chemical gradients in the sea. They left no bones, no footprints, but they left their mark in other ways, in the way they reshaped the chemistry of Earth's oceans and atmosphere. At some point, one group of these tiny organisms discovered something revolutionary: photosynthesis. Using sunlight, they could convert carbon dioxide and water into sugar, releasing oxygen as a waste product. It was a slow process, but the effect was enormous. At first, oxygen reacted with iron in the oceans, turning waters red and filling the seabeds with rust. But eventually, it leaked into the atmosphere. This was the great oxidation event. Oxygen changed everything. It poisoned many early life forms, but for others, it was a powerful new energy source. It allowed the evolution of more complex metabolisms. It turned Earth's skies blue. It paved the way for the next chapter: complexity. For nearly 2 billion years, life remained microscopic, but it was not static. Some cells began to live inside others, not as invaders, but as partners. One swallowed a bacterium and kept it not as food, but as a power source. That bacterium became a mitochondrion, the engine of complex cells. Others may have captured photosynthetic bacteria, ancestors of chloroplasts. These unions gave rise to a new kind of life, the eukaryotic cell, larger, more organized, with internal compartments. With this leap, life's possibilities expanded. Multicellularity became possible. Specialization, structure, motion. But that leap was still to come. For now, the world was still ruled by the microscopic. Layers of bacteria formed mats in the shallows. Slime-like colonies covered the seabed. The surface was quiet, but beneath the waves, life was humming. Earth's crust shifted. Continents slowly began to rise. Ice ages came and went. Meteorites struck. Comets delivered water, carbon, perhaps even amino acids. But through all of it, life persisted. Not quickly, not dramatically, but steadily. Adapting, refining, preparing. It would take billions of years before the first animals, the first trees, the first eyes. But the seed had been planted, and from that seed would grow coral reefs and jungles, ant colonies and coral atolls, dinosaurs and birds and whales and primates. Everything alive, every leaf, every feather, every thought, traces its lineage back to those first silent cells. Life had emerged. For billions of years, life had remained small, invisible to the naked eye. It drifted in oceans, clung to rocks, multiplied in silence. But Earth was changing. Its continents shifted. Its climate warmed and froze again. Its oceans grew richer in oxygen, thanks to tiny photosynthetic organisms working without pause. And eventually, the world was ready for something more. Around 600 million years ago, cells that had once lived alone began to cooperate. They formed colonies, then simple bodies. Some cells specialized, some for movement, others for digestion, others for structure. The first multicellular organisms appeared. Soft-bodied and slow, they crawled or floated along the seafloor. They left behind strange impressions in rock, leaf-like, ribbon-like, unfamiliar. These were the ancestors of all complex life, and they were just the beginning. Then, about 541 million years ago, something extraordinary happened. In a geologic blink of time, life exploded in diversity, form, and behavior. Scientists call it the Cambrian explosion. Within a few million years, almost all modern body plans appeared. Creatures with legs, eyes, shells, claws, fins, spines. Predators hunted, prey defended. Animals burrowed, swam, crawled, and saw. The seas became crowded with life. Why this sudden leap? No one knows for sure. Maybe oxygen levels finally reached a threshold. Maybe new genes unlocked more complex forms. Or maybe it was simply evolution, ready and waiting for a chance to stretch its wings. Whatever the cause, life had crossed a threshold, and it would never go back. For hundreds of millions of years, life flourished in the seas. Fish evolved jaws and bones. Plants colonized land. Arthropods followed, insects, spiders, scorpions. Then amphibians crawling from water to land. Forests rose, oceans teemed. Dinosaurs thundered across continents. Flowers bloomed under buzzing wings. But evolution was never a straight path. It was shaped not just by progress, but by disaster. Earth, for all its beauty, is not a gentle place. Volcanoes erupt, continents crash, oceans rise and fall, and sometimes the planet resets the stage. Over the last 500 million years, Earth has faced at least 5 mass extinctions. Events where 75% or more of all species vanished, often within a geological instant. The most devastating was the Permian-Triassic extinction, about 252 million years ago. Triggered, perhaps, by massive volcanic eruptions in Siberia, this catastrophe warmed the planet, filled the air with carbon dioxide, and suffocated the oceans. Over 90% of marine life disappeared. Forests collapsed. Insects vanished. It was called the Great Dying, and yet, life recovered. Each extinction was a tragedy, but also an opening. With old species gone, new ones rose. Mammals emerged after the dinosaurs. Birds evolved from theropod ancestors. Grasses reshaped landscapes. And primates, climbing through trees, began to observe the world. Evolution, it turns out, is not a ladder. It is a tree, full of branches. Most end in silence. Some split again and again, and one, on a single planet, led to something that could look up and ask, where did we come from? But that branch was still far in the future. Back then, Earth was alive in every corner. Reefs, deserts, tundras, jungles, each full of unique species adapted to their moment. And yet, extinction always lurked. A meteor struck 66 million years ago. It ended the age of dinosaurs in one awful day. Dust rose, fires spread, skies darkened, plants died, and the great reptiles that had ruled for 160 million years vanished, except for birds, who survived and still sing today. Their fall made room. Mammals, once small and nocturnal, diversified. Some took to trees, some learned to walk, some grew brains, built tools, made fire, But that, too, is a different chapter. For now, we reflect on what evolution is. Not perfection, but persistence. Not a plan, but a process. Driven by change, shaped by chance. It is how life survives the chaos of a shifting world. Extinction clears the way. Evolution fills the void. It is a dance of loss and renewal, over and over, for billions of years. We often imagine extinction as an end, but on Earth, it has always been a beginning. After fire, new forests. After silence, new song. After darkness, a chance for something unexpected. That something would one day begin to wonder about its place in it all. From the ashes of extinction, life continued. After the fall of the dinosaurs, mammals inherited the earth. They filled forests, climbed trees, walked plains, swam oceans. Some grew massive, others stayed small, and in the canopy of ancient jungles, something new was forming, not a creature of great strength, but of growing awareness. It began with primates. They were agile, social, and curious. Their hands could grasp. Their eyes faced forward. Their brains, compared to their size, were large. For millions of years they lived in the trees, but the world below was changing. Around 7 million years ago, in the shifting landscapes of Africa, a few of these primates came down from the trees. The forests were thinning, the climate was drying, and survival demanded adaptation. They stood more upright. They walked on 2 legs. Freeing the hands changed everything. Now they could carry, shape, and throw. They could gesture, point, signal, and eventually they would speak. These early hominins lived in small bands, moving with the seasons. They scavenged, hunted, gathered roots and fruit. They used stones to crack bones, to cut meat, to dig. Simple tools at first, but tools nonetheless, extensions of the mind. Over time, the tools grew more refined, and so did the minds that wielded them. By 2 million years ago, a new lineage emerged, Homo, the genus to which we belong. They were taller, leaner, more clever. They crafted sharper tools. They controlled fire. Fire was a turning point. It meant warmth, safety, and cooked food. It meant gathering in the dark, around flame, sharing and remembering. It stretched the day. It softened food. It may have softened us. The brain grew. Faces changed. Gestures became sounds. Sounds became language. And with language came memory, planning, imagination. They began to think ahead, to tell stories, to pass down knowledge. These early humans spread beyond Africa. Over tens of thousands of years, they crossed rivers, deserts, and mountains. They reached the Middle East, Asia, Europe. They braved cold steppes and icy coasts. Some turned north, adapting to glaciers. Others followed the shores, building boats, crossing islands. They hunted mammoths, fished in rivers, tracked herds across continents. They painted in caves. They carved bone and ivory. They buried their dead. They left symbols, the first hints of meaning beyond survival. And around 300,000 years ago, a new species appeared in Africa, Homo sapiens, wise man. They looked much like us. They were us. For tens of thousands of years, they lived alongside other humans, Neanderthals, Denisovans, Homo erectus, and others now gone. Sometimes they fought. Sometimes they mingled. Some of us carry the echoes of those encounters in our very genes. What made Homo sapiens different? It wasn't just the tools. It wasn't even language alone. It was the ability to imagine things that didn't exist, to believe in shared stories, to cooperate in large groups, not just through strength, but through myth. They could plan hunts, divide labor, build communities, share gods and laws. Ideas became more powerful than muscles. They transformed the land around them. tamed fire, then dogs, then crops. They settled, they built. Villages became cities. Stories became religions. Memory became writing. And yet, for most of human history, we remained nomads. Wandering with the stars, watching seasons pass, living close to the earth, learning its rhythms, naming its animals. It was only recently, barely 12,000 years ago, that agriculture began. We planted seeds, we raised herds, we stayed in one place. Civilization was born. And from there, in a blink, pyramids, empires, music, wars, books, cathedrals, nations, machines, satellites. In just a few millennia, we reached heights and dangers no species had ever known. We shaped the land. We reshaped each other. We reached the moon, split the atom, wired the planet. And all the while, we carried inside us the ancient instincts of those who once walked barefoot through African grasslands. We are a young species. Our story is barely a page in the book of life. Our bones still bear the memory of trees. Our minds still ache for firelight and voices in the dark. And yet, we build cities that glow from orbit. We send probes beyond the solar system. We look back at our own planet as a pale blue dot, fragile, living, alone. How did Stardust learn to speak? How did molecules become memory? We still don't know. But it began with upright steps, sharp stones, shared stories, and the need to understand our place in it all. We are not the end of evolution. We are part of its unfolding, a branch, brief and burning, in the great tree of life. For all our triumphs, all our discoveries, we are still a species balanced on the edge of time. The earth has carried us for hundreds of thousands of years, but it has existed for billions before us, and will last for billions after we're gone. Our moment is brief, but what we do with it may echo far beyond our time. Today, Earth spins through space as it always has, tilting, orbiting, breathing through cycles of weather and life. But its future is not fixed. The planet changes, and we have become part of that change. We have reshaped the surface, cut forests, redirected rivers, built mountains of steel and glass. We've altered the atmosphere, released carbon, thickened the air, warmed the oceans. Species disappear, ice melts, storms grow stronger. Some call this a new epoch, the Anthropocene, an age where one species changes the fate of an entire world. And yet, for all our power, we are still vulnerable. A single asteroid could end us. A supervolcano could darken the skies. A pandemic, a solar flare, a war, an error. Our tools give us reach, but not immunity. Still, we are not helpless. We are the only species we know of that can imagine its own extinction and choose to prevent it. We build telescopes to watch the skies. We store seeds in vaults. We write books, train models, share knowledge across oceans. We look for life elsewhere, not just to find others, but to understand ourselves. Beyond Earth, space is vast, silent, and hostile, but it calls to us. We've walked on the moon. We've sent robots to Mars, to Jupiter's moons, to the edges of the solar system. We've photographed black holes. We've listened for signals from the stars. And someday, maybe soon, maybe centuries from now, we may leave Earth not as explorers, but as migrants. Perhaps we'll build cities under domes on Mars. Perhaps we'll sail among the moons of Saturn. Perhaps we'll send frozen embryos to distant stars, or upload minds into machines that cross the galaxy. Or perhaps we'll remain here, on this one fragile world, choosing to preserve, rather than escape. But even Earth has an end. The sun, stable and life-giving, is not eternal. In about 5 billion years, It will begin to swell, burning hotter as it enters its red giant phase. It will engulf Mercury, then Venus. And though Earth may escape its grasp, its oceans will boil, its atmosphere will strip away, and everything familiar will vanish. Long before that, life as we know it will likely be gone. Unless we find a way to move beyond this planet, our story will end where it began, in dust and silence. And yet, that does not mean it was meaningless. Meaning is not written in the stars, it is written in us, in the minds that wonder, in the hands that build, in the hearts that remember. Perhaps that is our greatest achievement, not the satellites or the skyscrapers, but the fact that we care, that we ask what happens next, that we plant trees whose shade we will never sit under, that we imagine futures we may never see. In the deep time of the universe, we are a flicker, a breath, but for that instant we burned with awareness. We looked up, we asked questions, we told stories, we reached for more. The future of Earth remains unwritten. It may be long and rich, or it may be short and silent, but so long as we endure, so long as there is one voice to speak, one mind to wonder, one spirit to dream, the universe is not empty, it is alive, and maybe somewhere out there, in another galaxy, on another pale blue dot, someone else is just beginning to ask, where did we come from? And so, from a singular flash in the dark to the quiet beating of a human heart, this is the story of everything. A journey from stardust to thought, from chaos to consciousness, from the void to us. The universe is not just around us, it is within us. And though our time is brief, our story is part of something eternal. Thank you for listening. Sleep well, and never stop wondering.